So this part of the videos is about parametrization. We're trying to parameterize the intersection of two surfaces, y squared plus z squared equal to 4 and x equal to 5y squared. Please remember y squared plus z squared equal to 4. It's just that the circular cylinder sitting like that lies on x direction, and in the y and z direction it looks like a circle down there. And then what is x equal to 5y squared? That's x equal to 5y squared, x equal to 5y squared. And you go up and you go like that. So basically it looks like that sort of a cylinder sitting on top of that. Now the question is saying, well, it's perfectly fine to say the curve of intersection of these two, and that's more intrinsic. And now basically what you want to do is to find a parameterization of it, and parameterization depends on t, but also gives us a vector function. And so here, parameterization, I start with, I have to parameterize each variable, and because it's a curve, it's just one parameter. Now, x squared plus y squared equal to 4 gives me the precalculus parameterization y to me. And what is that? Oh no, it's y squared plus z squared. That is y equal to square root of 4, 2 times cosine of t, and z equal to 2 sine of t, and t goes between 0 and 2 pi. Right, so that's the one. I already did two of my variables, parameterized two of my variables with this t. What is remaining is x, but x also is equal to 5y squared. So 5y squared, what is y? 2 cosine of t, so it's 5 times 2 cosine of t to power 2, which is 4 times 5, 20 cosine to power 2 of t. So if I write this out nicely, let's put it right next to this. It's going to be x is 20 cosine squared t, y is 2 cosine of t, and z is 2 sine of t. And that's the parameterization R of t. Now I want to know what this looks like. I'm having a hard time imagining it, right? So what do? I go to Geogebra in 3D app, and I enter y squared plus z to power 2 equal to 4, and then I enter x equal to 5y to power 2, and I get these two surfaces, right? And I can see that these are intersecting, and I can see that sort of a shadow. I just want to make sure that I know what those shadows are, right? So what do? I go, so in here I enter the parameter curve of 20 cosine to power 2 of t, and was 2 cosine of t, if you remember, cosine of t, and 2 sine of t, and t runs from 0 to 2 pi. And it perfectly gives me one of those parameterization, the top one of those parameterizations, basically. You can see that that's the intersection that you're expecting. And so what about the lower part? Okay, so what about the lower part? Why am I not seeing the lower part of this? And so let's see what is happening. Oh, I just needed to do this, and I see both pieces, the upper and the lower. And so basically when sign is it takes negative value, it gives you the lower piece of that. And so that's how it looks like. Okay. And it took me a few tries to zoom well, and now you can see that there's no upper piece and lower piece. They are all connected. Just looks that funky shape that goes about above and below like that. It's very smooth and nice.